Imagine if every single application in your company, hundreds of them, all lived behind a single intelligent front door that knew exactly where to send every visitor instantly.
That's not just a nice thought experiment. For a modern cloud application, it's a fundamental requirement. And it's an incredibly complex problem to solve at scale.
Okay, let's start there. I have a Kubernetes cluster. I'm running, let's say, a dozen different microservices. One for user accounts, one for product catalogs, one for payment processing. How do I let the outside world talk to them?
There are a few basic tools Kubernetes gives you. The simplest, conceptually, is a service of type load balancer. You can put this in front of your payment service, and the cloud provider, say AWS, will automatically create a dedicated, public-facing load balancer just for that service.
That sounds pretty easy. So what's the catch?
The catch is cost and complexity. If you have 12 services, you now have 12 separate load balancers. Each one has a public IP address and costs money, typically around $20 a month. For 100 services, that's $2,000 a month just for entry points.
Yikes. Okay, so that doesn't scale. It's like having a separate front door and a separate doorbell for every single room in a massive office building. It would be a nightmare to manage and incredibly expensive to build.
Exactly. And these basic load balancers are usually layer 4 devices. They just direct traffic based on port and IP address. They don't understand the language of the web, things like which website is the user trying to reach, or what's the specific path in their request. They're not very smart.
So we have this city of services, and we can't afford to build a dedicated highway interchange for every single one. We need a central station, something that can look at the incoming traffic and direct it intelligently. Where do we find that?
That brings us to the concept of ingress. The name is perfect. It's all about how traffic ingresses or enters the cluster. Instead of a one-to-one mapping, Ingress lets you define a set of smart routing rules for all your services, all in one place.
So it's less like a dozen separate front doors and more like a single grand entrance with a very sophisticated building directory.
That's a great analogy. An Ingress resource in Kubernetes is exactly that, a directory or a blueprint. It's a simple text file, usually YAML, where you declare your routing rules. You can say things like, all traffic for store.example.com should go to my storefront service. Or traffic for api.example.com/users should go to the user account service.
And you can get even more specific, right? Like sending traffic based on the path. So store.example.com/products goes to the product service, but store.example.com/checkout goes to the payment service.
Precisely. This is called Layer 7 routing because it operates on the application layer. It understands host names and URL paths. This allows you to consolidate all your traffic behind a single, powerful load balancer, which is far more efficient and cost-effective.
Okay, this seems like the core idea. As a developer, I just write this one configuration file, this Ingress blueprint, and I list out all my routing wishes. But a blueprint is just a piece of paper. Who actually reads it and builds the thing?
Right, and this is the most important part to understand about Kubernetes. The Ingress resource itself does nothing. It's just a declaration of desired state. To make it real, you need an Ingress controller.
A controller. That's a term we hear a lot in Kubernetes. It's a piece of software that's always running, trying to make the current state of the world match the desired state, right?
Perfectly put. The Ingress controller is an active agent running inside your cluster. It's constantly watching the Kubernetes API for Ingress resources. When it sees one you've created or updated, it springs into action.
And what does it do? Does it configure something inside Kubernetes?
It does, but its main job is to talk to the outside world, specifically to your cloud provider's infrastructure. If you're in AWS, for example, a very popular choice is the AWS Load Balancer Controller. Its job is to translate your Ingress blueprint into a real functioning AWS application load balancer.
Ah, so the controller is a translator.
It speaks both Kubernetes and AWS. I write my simple, cloud-agnostic Ingress file, and the controller handles the messy, specific details of provisioning the hardware, or in this case, the cloud service.
You got it. That's the magic. The developer doesn't need to be an AWS load balancing expert. They just need to declare their intent.
So let's go deeper on that. I've created my Ingress file. What happens next with the AWS Load Balancer Controller? What are the actual steps it takes?
Okay. First, the controller, which is a pod running in your cluster, sees the new Ingress object. It determines that a new application load balancer, or ALB, is needed, so it makes an API call to AWS to provision a new ALB for your cluster if one doesn't already exist for that Ingress group.
So it's literally creating new AWS resources on my behalf. That requires some serious permissions.
It does. You have to configure its permissions very carefully using a system like IAM roles for service accounts. Once the ALB exists, the controller then reads the rules from your Ingress file. For each rule, like route/products to the product service, it creates a corresponding listener rule on the ALB.
So it's mapping the Kubernetes concepts to the AWS concepts one for one.
Exactly. And it also creates something in AWS called a target group for your product service. A target group is just a collection of endpoints that can receive traffic. And here's a really critical and efficient detail. The controller doesn't just point the ALB at some generic service endpoint within Kubernetes.
What does it do instead?
It actually queries the Kubernetes API to get the specific private IP addresses of the individual pods that make up your product service. It then registers those pod IPs directly into the ALB's target group. This is called an IP target type.
Why is that so important? What's the benefit of being that direct?
It's more performant. It bypasses an extra networking hop inside Kubernetes' own internal routing called kubeproxy. The traffic flows directly from the AWS load balancer to the specific pod that will handle the request. It's faster and gives the load balancer more accurate health check information because it's checking the health of the pod itself, not some intermediary.
So the AWS Load Balancer knows the exact private address of every single pod in my application. And when I deploy a new version and the pod IPs change, the controller automatically updates the target group in AWS?
Instantly. The controller is always watching for changes to both the Ingress rules and the pods they point to. It ensures the ALB configuration is always in sync with the state of your cluster. It's a continuous reconciliation loop.
That is so elegant. There's a real beauty in that separation of concerns. As a developer, I can focus on my application's logic and simply declare, I need traffic for this URL to go here. I don't have to think about provisioning load balancers or managing IP addresses or network hops.
That's the entire philosophy of Kubernetes in a nutshell. It's a declarative system. You declare the what, and a fleet of controllers work tirelessly to deliver the how.
And this controller pattern isn't just for Ingress, is it? It's everywhere.
Everywhere. The thing that creates pods from a replica set, that's a controller. The thing that notices a node has died and moves its pods elsewhere, a controller. The AWS Load Balancer Controller is just a particularly powerful, specialized example that extends the cluster's awareness out into the cloud provider's own infrastructure.
It feels like a true extension of the data center, making the cloud provider's managed services feel like native parts of your own cluster.
It is. And the community continues to build on this. The Ingress API, while powerful, has some limitations. So there's a newer, even more flexible standard emerging called the Gateway API, which applies the same controller pattern with even more granularity and role-based separation. But it's all built on this same fundamental, beautiful idea.
What idea is that?
That you can solve incredibly complex infrastructure problems by separating the declaration of intent from the work of implementation. You just have to say what you want, and the system makes it so.
The key takeaway for me is that elegance in engineering often comes from defining the right boundaries. The Ingress object is a simple declaration of intent, and the controller is the powerful engine that makes it real in a specific environment like AWS.
It's a system of trust powered by APIs.
I'm Maya.
And I'm Arjun. See you tomorrow.